So now we have the frame model corrected up, cleaned up to where each edge is represented by a smooth curve that join exactly at the ends, and in general, as far as possible, each area that we're talking about has got 4 sides. There are some exceptions where, for instance, this area just here fitted more naturally with 3 sides. A 3-sided shape is okay, but we try to aim for a 4-sided shape in general. And so now we go to start putting in meshes, and in general we add the meshes between 2, 3 or 4 edges, and we always aim for 4 edges. And there's a question right at the beginning about what sort of mesh density that we should have. In other words, how many threads there should be in the mesh. And there's a good argument not to go to huge numbers, because it makes the drawing just look complicated. It's nice to use even numbers, because strangely an even number, if you wanted to divide it into 2, you will get 2 even meshes from it. It's a bit counterintuitive, that, but it's best to stick to odd numbers. And because most of these panels have got more distance in the and we're talking very vaguely here in the sort of the X direction rather than the Y direction, we'll specify it to where we have 25 points in the X direction and 13 in the Y. We'd go ahead now and just start that we're going to add some meshes, select the bottom edge and select those edges like that, and we get a mesh drawn in. You can see by looking at the curve shape here that this level of mesh density is entirely adequate to describe that shape, and our plan is that this shape here will eventually become a single panel. On the triangular meshes, let's add another mesh. We'll add the mesh for here, we'll add the bottom edge. When we click near the bottom edge, we'll have to choose between the existing mesh and the curve. So we choose the curve. We'll choose now the right hand edge. We'll skip the top edge. Whenever we're making a triangular mesh, you want to skip the top edge, and we skip that by hitting the enter key, and now we'll select the left hand edge, and now we get the mesh drawn in like that. And the meshing just continues apace. Doing that, you need to try and keep the definition of bottom, top, right and left fairly consistent. And when we go onto some of these cells, some of these shapes that are rather smaller, we'd probably choose to reduce the mesh density down to smaller values. Now, when we come to a piece like this that we want to mesh, we have a little bit of a difficulty, because there is a bend in one of the edges. In fact, that edge is formed out of 2 boundary curves just here. To look at that more closely, I'm going to use a sort of a rhino trick, and that is that I'm going to select those 5 edges, and then I'm going to use a rhino tool to invert and hide, and this isolates those objects and lets me work just on those objects on their own in isolation. Now, to get a mesh which is going to cover this surface, I could of course join these 2 elements together and then use an edge mesh between those edges, but there's no guarantee when the mesh went in that a mesh corner would actually catch this corner just here. So the most accurate way to do this is to turn both of these edges, in fact all 4 edges, into polylines that are guaranteed to catch the corner, and then convert that into a mesh. And we do that with the Prepare Data tool. Convert several curves to a polyline. I'm going to say that this is a reasonably long edge there, so I'm going to put in perhaps 21 nodes in there. I'm going to select these 2 curves and modify the poly and what we get is a polyline drawn in which includes a node exactly at what was the corner. That's going to become one edge of the mesh, and so I need the same number of nodes on this side, so I'll do the same conversion on this side. And actually, if I pull up in Rhino now to look at the points, we can see we have the same number of points on either side. The two end ones here, the two end curves there, they also need to be forced to have the same number of nodes. 7 looks to me to be enough to go across there, and if I use the normal convert curve to a poly, then I can do several curves at the same time because it won't try to join them into a single curve. And so now what I've got is 3D poly boundaries with the same number of nodes on each side, with the node actually capturing the bend in that panel just there. And so now what I can do is on the add meshes, I can say I want to add meshes using those poly edges. At that point I no longer have a choice of the nsurf and msurf, the number of threads in the mesh, because it's going to be determined exactly by the nodes in these polylines. So all I do is go to add a mesh, I get my usual prompts to select the bottom edge, the right edge, the top edge and the left edge, and a mesh is drawn in which exactly goes to that corner point. At that point I can show the rest of my objects, and you can see how that fits into the rest of the structure.